Alright, you guys, so today we're going to finish up section 10.3 on ellipses. I didn't finish with the last lesson because I wanted you to digest these formulas here, which I'll make bigger in a little bit. In the meantime, I just wanted to do a quick review of some things, okay? So an ellipse is this sort of flattened circle looking thing, right, in the plane. If it has its center at the origin, then the formulas, remember the center is HK, so if the center is 0, 0, then you're going to have something of the sort like x squared over b squared plus y squared over a squared for a vertical axis, so it would be this thing here. Or if you had a horizontal axis, you would have a formula x squared over a squared plus, y squared over b squared, all right? But I just wanted to review the important characteristics of the ellipse, regardless of where the center is. So first and foremost, we have a major axis, right? And the major axis is either going to be horizontal or parallel to the x-axis, or vertical or parallel to the y-axis. If it's horizontal, your major axis is horizontal, then again your center is still going to be HK no matter where it's located, right? And this distance A is the length from the center to a vertex. All right, so you have the vertices here along the major axis, the co-vertices are on the minor axis, and this is called B. So in your formula, if you have x squared over b squared, then B, whether it's, well, let me use A. If I use A represents the major axis only, and B represents the minor axis only, and the distance from the center to a co-vertex is just B. Likewise here, even though my major axis is vertical, the distance from the center to a vertex is called A, and the distance from the center to a co-vertex is called B. All right. So let's bring this up here because now you're going to be introduced to the general form of the equation of an ellipse. So there's a standard form, which you're already familiar with, and then there's a general form. And you can tell when you're in the general form because the right-hand side of the equation will not be 1, right? So remember from your little formula sheet that I posted, whether the axis is vertical or horizontal, right? You always had a 1 on the right-hand side of the equal sign. So if you don't have a 1 there, then that means you're in general form. The right-hand side does not equal 1. So the first thing you have to do if you want to sketch an ellipse is you have to get it out of general form and put it into standard form. All right? And so you do that by making the right-hand side 1. How do you make it 1? Whatever the number is on the right-hand side, you divide each term, both sides of the equation, by that number. So for example, here I divided every term, both sides, by 36. Why? Because 36 divided by 36 gives me the 1 that I need here. Now over here, I knew that 4 went into itself once and into 36 9 times. So you're going to want to simplify if you can. So what we have is x squared over 9 plus y squared over 36 is equal to 1. All right, and then the other thing you're going to want to do is these are going to be perfect square numbers for the most part. They don't have to be. You could have like the square root of 3 under there or the square root of 2. But for the most part right now, they're going to be perfect square numbers. So how you want to write them is, the base raised to the second power since they're squares. So, I know that 3 squared is 9, so I'm going to write it as 3 squared. And I know that 6 squared, or 6 times 6, is 36, so I'm going to write that as 6 squared. So that helps me identify my A and my B. Why? Because the A is going to represent the length from the center to a vertex on the major axis, and the B is going to represent the distance or the length from the center to the co-vertex on the minor axis. All right. Now another thing to keep in mind, so some quick tricks. Oh, it's 9:13. I'm tired. I've been working since 5:45, so I apologize. The larger the bigger the number under y means that so if the bigger number is under y, 6 is bigger than 3, right? Then you're going to have a vertical major axis, meaning that, you know, your ellipse is going to look something like that, right? And if the larger number is under x, well, then that means something parallel to, or the x-axis itself is going to be the major axis, all right? So again, I can't stress enough that A always represents the major axis. The length of the major axis would be 2 times A. So you can think of that distance A as sort of like the radius of a circle, right? The radius is half. It's the distance from the center of the circle to a point on the circle. Circles don't have vertices, so the ellipse is the same idea. So in your book, in example 2 on page 710, they want you to take this equation up here, and they want you to do 2 things. They want you to identify the center and the vertices of this ellipse, and then they want you to sketch it. Okay, so look, we got this thing into standard form. X squared over 3 squared plus y squared over 6 squared equals 1, right? This is the standard form. We did that by dividing every term, both sides, by 36, simplifying if we could, right? And then rewriting those bottom numbers as some number squared. Now the bigger number, 6, is under y. So what I know is I'm going to have a vertical axis. And since the distance from the center, by the way, is at 0, 0, right? Because we have just x squared and y squared on top. Remember, this is my A and this is my B. So the vertices lie along the major axis, and they're A units from the center. So I'd go up 6, plot a point, down 6, plot a point, and the length of the major axis is 2 times 6, or 12, right? 2 times A. And then for the co-vertices, different color. Guess what? From the center, I'm going to go 3 to the right and 3 to the left. And my co-vertices are plotted on my minor axis. Then I can connect these with a smooth curve. Terrible ellipse, but you get the drift. All right? So they want us to sketch it. The sketch is done. They wanted us to identify the center. That's easy. The center is 0, 0. And they wanted us to name the vertices. Now, these are all vertices, all 4 of these. Okay? It's just that when they say vertices, that just means the vertices with respect to the major axis only. So the vertices would be, so to get to this vertex here, I start at 0. I go up 6 in the y direction and 0 in the x direction. So it's the point 0 plus or minus 6, right? 0, negative 6, 0, positive 6, and that's where your vertices are going to be. Here's another example. So they have x squared plus 9y squared equals 81, and they want you to sketch, identify the center and the vertices. Okay, so again, this is in general form, not standard form. So I'm going to divide every piece, every term, both sides by 81, because my first step, my first goal, come on, is to get the right-hand side equal to 1. So I've got x squared over 81, plus, now 9 goes into itself once, and it goes into 81 9 times, so I've got y squared over 9 is equal to 1. Right, so there's my standard form. And I'm going to simplify it just a little bit more by rewriting this as something squared. Well, I know that 9 squared is 81, and I know that 3 squared is 9. Now look, the bigger number, 9, so it's 9 versus 3, right? The bigger number is 9, and it's under x. So what that means is that I should have a horizontal major axis. And not only that, I already know my center is at 0, 0. So my center is at 0, 0. Now, remember, this would be my A and this would be my B, right? So what I'm going to do here then is I'm going to go ahead and plot these things. So horizontally, I'm going to go to positive 9, a little bit more, negative 9, and those are going to be the vertices of my major axis, whose length is 2 times 9, or 18. if I'm asked for it. Likewise, I'm going to plot the point 0, 3, 0, negative 3, and plot my co-vertices, and my ellipse is going to look something more like that. Okay, so I know my center, I made my sketch, and the coordinates of my vertices, well, I have to go out 9 in the x direction and 0 in the y, and over here I got to go out negative 9 in the x direction, 0, so you can write it as plus or minus 9 comma 0, and that would be fine for the coordinates of your vertices. Okay, now let's look at this form, and let me write down what we want to find. And this is way too blown up here, so let me just bring this up a little bit. All right, so we want to find the center and vertices of the ellipse x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. Whoa, yeah, sometimes these things are really big. All right, now we have to put this in standard form because those are the formulas we know, right? That's what we're familiar with. So we have to put them in standard form, and how you're going to do this is you're going to group like terms. Gosh, this thing's getting on my nerve. Try again. There we go. We're going to group these things together in terms of like terms, all right? And then we're going to have to complete the square, all right? So this is what I'm going to do. I'm going to put the x's and the y's together, but they're going to be on the same side of the equal sign. And okay, I'm sorry about this. I've been filming all day, and this thing just wants to give me a hard time right now. So maybe it's tired. All right, so let's do this. So we're going to do x squared plus 6x, and I'm going to put a box, plus 4y squared minus 8y plus a box. And if I have a constant, I'm going to move it over to the other side by performing its opposite operation. So this is plus 9, so that means I have to minus 9. And I'm going to add a box and a box. All right, so this is a trip down memory lane. We're going to complete the square. So I have my x's together here, and I have my y's together here, and I have my constants together on the other side. Constants, right? And if I'm going to be adding something here and adding something there, I'm adding 2 boxes on the left, I have to add 2 boxes on the right to maintain equality. So this one is okay. I'm going to leave that like that for a second. But this one, I can pull out a 4 if I want to. So I'm going to have plus 4 times y squared minus 2y plus the box is equal to negative 9 plus box plus box. So remember completing the square. Over here you're going to cut the middle term in half, so half of 6 is 3. You're going to put that in the box there, and don't square it, just write it as 3 squared. Now over here we've got to be a little bit careful because we have this 4 and we can't forget about it. But again, at this point here, we can cut the middle term in half, so half of 2 is 1, and we're going to square that. Alright, now look, I added 3 squared to this box, so I'm going to add 3 squared, or 9, to the first box. And to the second box, here, I'm not going to put a 1 in there, I'm going to put a 4 in there, because I have to multiply whatever I pulled out to that, because remember I factored before knowing what this number was. So 4 times 1 is a 4. So what we've done then is we've completed two trinomials, two perfect square trinomials. This can be written as x plus 3 the quantity squared. This one can be written as 4 times y minus 1 the quantity squared. And over here we're going to have a negative 9 plus 4 is 4. Getting close. Now remember, the right hand side of this thing needs to be a 1, so I'm going to divide through both terms by 4. When I do that, I'm going to have x plus 3 squared over 4 plus 4 times y minus 1 squared over 4 is equal to 1. And now I'm going to simplify that a little bit because I see that those two 4's cancel. So I'm going to have x plus 3 squared over 2 squared plus y minus 1 squared over, now look, this is going to be a 1 down here. So over 1 squared is equal to 1. So right away I know my center is HK, right? So the center of this thing is going to be negative 3, positive 1. Remember, it goes opposite the sign you see in the form. Let me move my mouse out of the way. Okay, so we got the center. Now let's find the vertices. Well, let's see. 2 is bigger than 1. 2 is under x, so that means I'm going to have a horizontal major axis. So I would go 2 in the x direction, oops, from my center. That's supposed to be a tick mark, not a point. The center is at the point negative 3, positive 1. So here's my center right here. And from that center, I need to take this center point, which in the x direction is negative 3, and I need to go 2 places to the right. So where I'm going with this, so here's my center. My major axis is 4, or 2 to the left and 2 to the right of that center. This is my major axis. Now my minor axis is going to be 1. So, well, this is a terrible picture, but if I go 1 above and 1 below, this is going to be my minor axis here. So my ellipse is going to look something like that. Make sense? So the coordinates of my vertices are, so look, I'm moving in the x direction, so I'm going to have a coordinate there, right? So my vertices, I'm going to have one at negative 1, 1, and I'm going to have another one at negative 5, 1. You notice in the vertical direction or in the y direction, they're not going to change because they lie on the same line. The only thing that's going to change is the x coordinate because they're in different positions. So it's going to be negative 1, 1 and negative 5, 1. And that's it. Okay, we're going to do another example. I don't think this is focused. Let's try one more time. It just does not want to focus up tonight. Oh my gosh. Okay, good. Looks like we're there. Alright. So, we want to find the center and the coordinates of the vertices again of the following. 9x squared plus 49y squared plus 18x minus 294y plus 9 equals 0. So here we have the general equation. We need to put this thing in standard form, and we're going to have to do it by completing the square. So first we're going to group our x's and y's together. We're going to move our constant over to the right hand side. We're going to add some boxes on the left and the right, and then we're going to complete the square and simplify it. So we're going to have 9x squared plus 18x plus the box plus 49y squared, they could have spared these big numbers, minus 294y plus the box is equal to, now remember I'm going to move this 9 over, so I have to subtract it, plus a box, right? 2 boxes on the left, 2 boxes on the right. Over here in this part here, I'm going to pull out a 9. We have x squared plus 2x plus the box. Over here, I'm going to pull out a 49, I hope. Let's see, it's 294 divided by 49. Yeah, so I'm going to pull out a 49. And we're going to have y squared minus 6y plus the box. Now remember, on the right hand side, instead of just box, I can make life easy on myself, and I can write plus 9 times box plus 49 times box, right? So again, you cannot forget about these numbers here that you pulled out, and you have to multiply them respectively to those boxes. So now let's complete the square here. We have 9 times x squared plus 2x plus, well, half of 2 is 1, and we square it, and we're done, right? Over here we're going to have y squared minus 6y plus half of 6 is 3, and we're going to square it, and we're done. And now I've got to put a 1 and a 3 in the boxes, like that. Okay, so I changed my boxes to parentheses, but there, boxes, okay? Over here, I have a perfect square trinomial. This is going to be 9 times x plus 1, the quantity squared, plus another perfect square trinomial. This is going to be y minus 3, the quantity squared, is equal to negative 9 and 9. Those are going to cancel. And so what we have is 49 times 3, and that's going to give us 147. We've got a problem again because the right hand side is not equal to 1, so I need to divide both sides by 147. And 147 divided by 9 does not go in evenly. That's terrible. So let's see. Okay, so 3 goes into 9 3 times, and 3 goes into 147 49 times. So what I have is 3 quantity x plus 1 squared over 49 plus, now 147 divided by 49, so this goes into itself once and this goes into itself 3 times, so I've got y minus 3 quantity squared over 3, and that's going to equal 1. So there's the standard equation, and I can write this a little nicer. So square root of 49 is 7 squared, right? Plus y minus 3 squared over square root of 3 is the square root of 3 squared. So my bigger number is under x, so I would expect a horizontal major axis, right? So that's my A, this is my B. So let's see here. The center, by the way, is at negative 1, 3. So I'm going to go ahead and plot the center. There's my center. And from the center, I'm going to go a units to the left and to the right, because remember, this is under x, so the major axis is going to be horizontal. So I've got to go over 7 units. So there are 7 units to the left. Here's 7 units to the right. And there's my major axis, 14 units long. Right? The vertices, the coordinates of the vertices, well, to get to this vertex, I've got to go over yeah, this is 6, right? From here, so 0, 1, 2, 3, 4, 5, 6, up 3. So I've got a vertex 6, 3. And the other vertex, so I've got to go over, I'm going even further here, right? I'm going 1, 2, 3, 4, 5, 6, 7. Oh, that's not right. 1, 2, 3, 4, 5, 6, 7. So here we've got negative 7, 3. Negative 8. I knew I was out of there. Sorry, negative 8. Okay, so we have 6, 3, negative 8, 3 are the coordinates of my vertices. My center is negative 1, 3. And, you know, if I want to, I know that my co-vertices are root 3. Well, what's root 3? Throw it into your calculator. It's going to be bigger than 1.41. In fact, it's 1.7. So you can go up almost 2 and down that much. And so your oops, up 2, down 2. So it's going to go something like that. Again, terrible picture, but that's what matters. So you're going to have some problems to try on WebAssign. And if you need more help completing the square, let me know. I will open up the problems for 9 o'clock tomorrow morning, and they will be due on Thursday. Have a good night.